Okay, so hello and welcome to this session with D-Fend Solutions, who we are delighted to have as a co-sponsor for the International Airport Online Summit. I'm Craig Waters, editor of International Airport Review, and joining me now is Jeffrey Starr, the Chief Marketing Officer at D-Fend Solutions, who is going to focus on counter-drone concepts for airport airspace control and continuity. Just to let the audience know that we are running a live poll during the presentation, so please head over to the polls tab on the viewing platform to cast your vote to the question we are running. If you do that now, we will then reveal the results in just a few moments' time. Jeffrey will also take some questions at the end, so if you want him to expand on anything or if you have a question to ask, then please do use the questions tab on the platform. So Jeffrey, let's get started with the presentation. It's now over to you, please. Thank you.
Thank you, Craig. And yes, in fact, counter-drone concepts specifically at airports is a subject I feel pretty passionate about. So I'm excited to talk to this great audience. I've seen we have great representation from a wide range of airports. And I want to very simply start and end this presentation with some video that focuses on some counter-drone use case scenarios and solutions. So let's get that started, and then we'll jump right into the agenda. Building on that, we can now jump right into the agenda. That gives you a little bit of background on us, which I'll expand on in a minute. We want to specifically talk about the nature of this threat and the environmental factors, specifically at airports. People talk about counter-drone in general, and that's gotten a lot of attention, but we want to really focus on this specific use case. Some of the challenges and considerations that make counter-drone operations very different in an airport environment than elsewhere. We also want to start a discussion, which we feel is not held enough in the industry, about differentiating between the different drone threats. Not all drones are alike. You should not treat this issue with a blanket approach. We want to understand how you prioritize and differentiate between different drone threats. Traditionally, these technologies have come from the counter-UAS military space. We want to talk a bit about what happened when those technologies have been applied to civilian airport situations, where they fulfill and where they may fall short or have special advantages, and what different new special capabilities are needed at airport environments for a more controlled and safe and continuity-based approach. And then we'll talk about the deployments that you need in an airport situation. And we don't only want to talk about the present, we want to talk about the future. When you talk about the drone threat with new drones coming on the market all the time, you always have to anticipate and be a drone threat ahead. And then we want to kind of wrap it up in a conceptual way and kind of go through the main concepts that airports should look at when they're adopting their counter-drone strategy. And now we'll kind of just briefly in background, D-Fend Solutions, as I mentioned at the beginning, I personally and the company is very passionate about counter-drone solutions, specifically in the most sensitive, complex, and challenging environments, of which airports are at the top of the list. Airports are one of our main areas of focus and priority right now. We have many deployments at airports throughout the world. We really focused on making counter-drone solutions safe and scalable, and really protecting the most sensitive assets, including airports as well as other critical infrastructure, military, police, prisons, any kind of sensitive environment. We are very proud that we've been tested, selected, and deployed by the top tier of security agencies. Here you have 6 logos. It's just a representative sample to give you an idea. For example, some of the top federal US agencies that are under the DoD, DOJ, DHS, and that's just, again, a small sample of as well many of our customers, which also include a number of major international airports. Taking first a big step back and looking at counter-drone incidents more broadly, or drone incidents, I should say. The upper left is probably the news item that most of you are familiar with, which really was the beginning of major coverage of this space. The famous incident at Gatwick Airport at the end of 2018 with flights canceled, the airport shut down for hours, huge economic cost. And that's really a classic use case. And we'll talk about many more examples as well. Drones are not only an issue at airports. You have other scenarios as well on the upper right. Prisons, these are actual footage of drones being used to smuggle in contraband or mobile phones to prisons. Drones have been used to attempt to assassinate world leaders. You see on the lower left coverage of the infamous case of Maduro in Venezuela, where there was an assassination attempt using a drone. You also have drones being used to disrupt major media events at stadiums. In the lower right, you see coverage of a soccer match between Albania and Serbia, which was disrupted and actually triggered some violence and riots because of a drone incident. It continues in the upper left here. You see coverage of drones being used in asymmetric warfare by groups such as ISIS in attacks on allied or conventional forces. In the upper right, yet another governmental attack where what was thought to be a radioactive drone found on the roof of the Japanese Prime Minister's residence. In the lower left, you see drones being used to penetrate critical infrastructure, in this case by an activist group that isn't Superman, that's a drone decorated to look like Superman in order to penetrate a power plant and make a political point. The lower right is a news piece done specifically about a study by the University of Dayton to illustrate what happens when a drone impacts an airplane. Now, this study was controversial, and there were different viewpoints on it from both manufacturers and the university. There's a brand new study, very timely, which I'll talk about in a minute, with some very interesting findings as it relates to drones in an airport environment. So those are just some of the recent incidents that have been in the news, but what we really should emphasize here is the ubiquity of the drone, the accessibility of the drone as a trigger that's causing a lot of these potential incidents. All the drones that you saw in all of those stories could be easily accessible and obtainable by just about anyone for less than $1,500. In fact, most of those drones could probably be acquired for even much below that, for a few $100s, or built very easily with do-it-yourself components. So as drones have become more available, more accessible, and cheaper, the potential risk increases commensurate with that. Now, again, you saw an example here. There are many vertical environments, many use cases where drones can cause an incident. We are going to specialize very specifically on that third slice you see there. What are the implications or the specialized considerations you have to focus on in an airport airspace environment? Now, first of all, we should look at the different nature of the potential drone threats. And here, in a general way, you could kind of categorize them as three: the accidental, or the careless, or the reckless, if you will, of a collision. Not someone with necessarily bad intentions, but just simply carelessness could lead to a catastrophic event around collision. The other scenario is actually something intentional by a bad actor, a bad player, an actual attack. The other thing that could happen at airports is drones used for surveillance or espionage, potentially to plan a future attack or for other reasons. So there's many different types here, and the counter drone strategy needs to encompass and confront all three of these. Now, incidents. The Gatwick Airport incident at the end of 2018 that you saw the video of earlier, that was really a landmark. That was a turning point, a real milestone, which brought enormous coverage and attention to the issue. But it hasn't stopped. It's relentless. It's happening more and more. Every single month, there's an incident. And here you just have a couple of examples. That same month, at the end of 2018, there was another incident in Mexico, in Tijuana, with an actual collision. A month later at Heathrow, more than 40 flights were affected. That same month, at the beginning of 2019, 40 flights affected by an incident at Newark Airport. Dubai, the world's third busiest airport, shut down for half an hour. Dublin Airport, flights diverted. It continues. Milan, flights diverted. Frankfurt, 70 flights diverted. Madrid, delays earlier this year. Frankfurt, disruption in March. Another incident in Gatwick in March of this year. And again, even more recently in May, Riga Airport, Latvia Airport totally shut down. Perth, a near collision. Teterboro just this summer, another sighting and disruption. And I want to emphasize, this is just a small representative sample to give you a sense of the recent timeline. So these incidents are not stopping. And I'm sure many of you, I know we have a great cross-section representation in the audience of drone incidents. I hope most of you have answered the poll question. Craig, do we have enough answers yet that you can share some results in terms of how drone incidents are affecting some of the members of our audience?
Yeah, of course. So the poll question that we asked was, how many drone incidents have there been at your airport during the past 3 years? And the results are 57% have said no incidents, and 43% have said multiple incidents, with nobody choosing a single incident. So yeah, 57% no incidents, 43% multiple. What do you think of those results, Jeffrey?
Okay, that's interesting. So 43% of the audience has already experienced multiple incidents at their airport. So considering, that the trigger was, maybe a year or starting in 2018, I think it's only a matter of time, of course, where the remaining portion will also be affected. And I'm glad they're planning ahead by tuning into this presentation. So that's about what I would have expected. It's interesting that all of those who have suffered incidents, it wasn't a one-time thing. It was multiple incidents as well. So that's another interesting pattern. So thank you for participating in that poll. And you can see here that the nature of the threat is not one-dimensional. You can actually have multiple use cases. So for example, earlier we talked about not just airport, but attacks against world leaders. Now here you have an incident where they actually converged. So you don't only have to plan for commercial flight disruption, but for example, there was an incident very recently where there was a drone nearly hit by the US President's plane, Air Force One. So there you would have an example of a special flight that would require special protection, separate from the approach taken from the normal commercial scheduled flights. It may be a target by a nefarious actor. So that's an area where, for example, you might have to have a separate, dedicated, focused tactical strategy just dealing with an event or a VIP visit, different than the ongoing strategy. So that's another dimension that needs to be taken into account. So I did promise I'd share some results from a recent study, and I have to give great compliments and credit to the CNRC, the Canada National Research Council, who just completed a study, which was perfect timing to help me with my presentation. They just did a really comprehensive study. I'll talk about the parameters in a minute, but it was very thorough and very multidimensional. And basically, right here, I'm just sharing their bottom line conclusion about the high risk to aircraft. The one sentence which I thought summarized the study was the risk of impacting an aircraft at low altitude remains high from both malicious and careless operators. So both collision and attack as being major factors. This study is available in the public domain. They publicized it very well. You can read findings yourself. So you can easily get to this report. They did a really great job. And again, that's from this month, very recent study, the best study that I've seen recently on this topic. And I wanted to spend a little bit of time on the results that they published. What I want to emphasize was this study was very realistic in terms of the scenarios. They used typical is the word here, typical drones, typical planes at typical speeds. They focused on, for example, DJI Phantom 3 standard drone, which is one of your more popular basic drones, available, list price $1,000, but I looked it up on Amazon today, and it's already available for below $700, as you can see by the listing here. They focused on typical transport planes. They really focused on two areas which allowed them to go more in depth, and I'll share the findings in a minute. They focused on the windshields and the wings, two obviously critical components, and we'll see what the results were. And again, the speeds were typical with drones at 140 to 250 knots, which is commensurate with below 10,000 feet. And if you look at, first of all, the windshields, and it's very stark and very direct and very clear. The findings are this: considerable damage, a significant amount of glass fragments in the cabin, impaired vision, penetration and inhalation hazard to the crew, optics could be lost, emergency landing expected. I think that basically says it all. That's relating to the windshield. Now let's look at the wings. Okay, the wings. The bottom line was level 3 damage, according to the FAA assured damage level references. What does this mean? At the lower speeds, plastic deformation, extensive damage to the skin of the wing, damage to the underlying honeycomb structure. At higher speeds, even worse, skin fracture, severe deformations, secondary damage, and even penetration of drone debris into the fractured area. And you can see the rather stark pictures on the right. Again, this study is public domain. It's available. I was very impressed with the thoroughness of the experiments they did. But now that we've kind of assessed or summarized the potential damage, we have to look at the different nature of the different threats. Not all drones are alike. And this is a part of analysis which isn't being conducted thoroughly enough. Oftentimes, when an airport or another organization is looking at the drone threat, they tend to focus on things on, how many drones do I have to mitigate against? How many drone models? How many protocols? And then you wind up chasing every drone on the market, which isn't necessarily the best approach. Just like any risk exercise, you have to go through a risk assessment, a risk prioritization, and focus on the most dangerous drones, which are the highest risk. And here we've kind of simplified it or segmented it a bit into what we call high endurance drones. These are the drones that can go long distances and carry big payloads, which are obviously a major threat. And then on the right, you have another set of drones which aren't necessarily, which should not be ignored. They still can harass and they still can be a threat. But the smaller drones, typically Wi-Fi based, that can't travel long distances or carry a big payload, they're a different kind of factor. And then in the middle, you have kind of a wild card that you also need to take into account, which is the undefined or the do-it-yourself drones that people can make from their own components. All of these have to be part of the equation, but like any risk analysis, you have to prioritize, obviously, on what is most dangerous. And here's a kind of one potential analysis you can do, but given the fact that we're concerned with potential collision or worse, potential attack at an airport, you really need to focus on the medium-sized to larger drones that can go long distances and carry bigger payloads as part of the categorization and assessment of risks, drone risks to airports. Another way of looking at it is kind of the major threats, the minor threats, but again, those drones that can carry a big payload up to 12 kilos or travel distances of up to 20 kilometers, handling, using the latest protocols, things like Lightbridge and OcuSync. That's the bigger threat, the bigger potential. Having said that, ideally, you also want to take into account the other kind of drones that are smaller, but can still pose potential threat, but you have to prioritize like every risk analysis exercise. The other thing, besides the payload and besides the distance that the drones can travel, another important factor is very simple, the accessibility. In other words, their market share or their installed base. So people, you're more likely, obviously, to see the more popular drones. So that also has to be taken into consideration. And obviously, you want to be able to mitigate or counter the most prevalent drones on the market. So, and obviously, DJI has the highest market share. So those drones are often at the top of the list, but you have to really look at the handful of players which dominate the market. And while you also may want to cover some of the more obscure drones, you really definitely have to cover the more popular and prevalent drones. Moving on. Now, this is where we're really going to kind of dive into the technologies. Now, traditionally, I'm sure these technologies are technologies you've heard of or you've been familiar with. When drones first emerged as a threat to civilian airports, as was natural, as would be expected, the first technologies employed were those that came from the counter UAS military arena, which was obvious. And these technologies have been very successful historically in that arena. And they have a very important role to play in a multi-layered defense strategy. So, things like radar, optical-based solutions, directional RF-based directional finders, acoustical sound, all of those can play a role. However, when they were brought from their military realm background into the civilian airport world, they definitely carried with them certain drawbacks or certain challenges associated with them. For example, obviously radars can generate false positives, flying objects, not distinguishing between a bird versus a drone. Optical solutions requiring a clear line of sight, which civilian airports or in dense environments, highly urban environments, that may be something very difficult to overcome. Also acoustic, as drones become more quiet, acoustical based solutions are difficult. So all of these, again, they have a very legitimate role to play in a multi-layer approach, but they all have certain challenges associated with them as you move into the civilian airport realm. That's just on the detection side. It gets even more complex when you look on the mitigation side. Mitigation side, most technologies have really, and I'm simplifying a bit here to make the point more clear, to cover the most of the technologies that have been deployed, are really based on two things: either jamming or kinetic meaning physical. So jamming meaning disrupting the communication between the remote control pilot and the drone itself as a way to mitigate, or kinetic, anything physical, anything shooting at the drone with a projectile. It can be a bullet, it can be a laser, it can be a net, it can be a drone killing drone, but something physical that goes after the drone itself. And those have been the traditional technologies, again, for mitigation that came from the military world. Now, obviously there's some very serious drawbacks or challenges associated with that. Jamming disrupts communications, not only between the pilot and the drone, but other communications nearby or in the area. And when you're talking about a dense communication-rich environment like an airport, where there are lots of internal communications, lots of security communications, lots of passenger communications, you're going to have issues with anything that's jamming based. Kinetic and jamming both also carry with them risks of collateral damage. That can be from, even if the drone is successfully mitigated and falls to the ground, you have the potential there for the drone to hurt a person or a staff, a civilian, or cause property damage. And not just the drone, but the projectile itself, whether it successfully hits or doesn't hit the drone, there's again the potential for collateral damage from the projectile itself, hurting a person or causing property damage. So these are things that need to be taken into account if jamming or kinetic-based technologies are deployed. So as drones became more of a threat to civilian airports, new approaches were looked at, new approaches were needed. And that is very much in contrast. So when you really focus on the unique requirements in a sensitive environment like this, you start to focus more, you really start to get more pinpoint based on the communications specifically between the remote control and the drone pilot and the drone itself, and what you can do to disrupt that or to break that or to actually take control of that in a way that's going to help alleviate the problem without causing the associated problems that we mentioned earlier, like false positives, like collateral damage, like a disruption of communications. And again, it becomes even more acute in the mitigation phase, where here the approach is what we call taking control. So ultimately, for a safe outcome, to take control of the threat, to take control of the environment, to take control of the situation, ultimately relies on taking control of the drone itself, and really going towards a safe outcome and a safe landing in a sensitive environment. So this other technology, for example, would be RF cyber takeover, where you would actually have an autonomous system to detect and take control over the drone, take control of the situation by taking control literally of the drone itself and landing it in a safely designated zone. So that's what it is, and what it is not is equally important. As I mentioned, it's not based on jamming, not kinetic, and not based on line of sight. And then you have a different life cycle, managing the life cycle of the drone incident. And we very much believe in a life cycle based approach where you have to look at every step of the process. And this is where it gets very different with different technologies. So ideally, you want to obviously start with detection and alerting when a drone is detected in your defined zone. But then beyond that, you want to continue. And ideally, all of this is happening passively, autonomously, if you can, with your system. And then you want to track the location. You want to track the drone's GPS position. You want to see where it's going. But then you want to identify it. You want to identify the drone's model. You want to identify the unique identifiers of the drone itself, what some people call the tail number. And you need an IFF approach, and I'll talk more about that later. Identification, friend or foe. Remember, airports nowadays are deploying drones for all kinds of friendly, positive applications. You don't want to treat them the same way as a rogue drone. Then you want to get more information about the pilot and about the takeoff point. That's critical, really, especially if you want to send law enforcement for immediate apprehension or take other sort of action. You want that kind of information. And then you really want to have options, okay? Unlike with those other forms of mitigation, you really want the option of what we call a fend off, which is very simple. There might be a reason you don't want to take control and land the drone. You may just want to push it away, send it back where it came from, or have it hover in place. That's what we call a fend off. That's an important option. You may want to do that for regulatory or other reasons. And then ultimately, as I've said a few times, take control of the situation by taking control of the drone itself, landing it. And these two are very active, proactive, decision-based steps where you set a flight path for a safe landing, safe route, safe outcome, the safest possible outcome. So that's kind of a life cycle based approach to it. As I mentioned earlier, very important that you have IFF capability. There's a lot of good drone applications now, very positive, friendly, valuable drones doing things at airports like surveillance, like inspection. Now with traffic mobility, you'll have shipments coming in. All those drones, you want to continue to allow them to do their job. So you need this capability to identify friend versus foe. Ultimately, then you're faced with deployment questions. You want to customize your deployment according to the operational unique needs of your airport. Most airports, you'll want stationary antennas. You want stationary deployments on both omnidirectional as well as long-range directional, either at different parts of the airport or specifically to protect certain runways, especially when you have greatly large airports over extended areas. However, as I mentioned earlier, you may have special use cases where because of an event or because of a visitor or because of traffic or because of a situation, you may want to supplement that with some sort of tactical deployment in addition to stationary deployment for your counter drone system. But most airports, you're going to want that long range directional capabilities to enable detection and mitigation way before the situation can be more dangerous or more problematic. You also want to take into account, depending on the climate or the weather of your environment, whether you need certain kinds of ruggedization for extreme environmental conditions. But just, this is a picture of what I mentioned. You may want omnidirectional sensors, but you also want that long range capability for protecting runways and depending on your topology. Many airports, not all, you have airports in the suburbs, in rural areas, but airports that are in urban environments, you want to kind of complement what other counter-drone systems may be in the area with the local authorities who are also looking at this as a sensitive scenario, but you have to kind of coexist with other systems that are deployed in dense urban environments where the airport may be. So kind of to summarize from a conceptual point of view, we feel that these four concepts kind of help guide your approach, your philosophy of counter-drone. First of all, control. We put control above all. Again, to take control of the drone threat, take control of the drone itself. This is how you ensure continuity, by taking control of the drone. Safety. It's not enough to have an outcome of just getting rid of the rogue drone. You want a safe approach. You want a safe landing, a safe fending off, or a safe landing for safe airspace, safe continuity, safe outcome. You have to focus rather than chasing everything. Focus on the real risk, the most dangerous drones. And to do that, you want an approach that uses analysis, assessment, and prioritization of the risks. And then the future. Don't only worry about what's happening now, but the new threats, the new drones that are coming onto the market always need to stay a drone threat ahead. Now, there's one concept or theme that runs through all of these. And this is really where the new technology must kind of breaks with the past of the traditional technologies. And the focus here is on the keyword continuity. Ideally, you want an incident, how shall I say, not to become an incident. Ideally, you want to mitigate and detect way before it becomes a danger in a way that allows everyday life to go on. Communications, transportation, and commerce. You ideally want that to go on uninterrupted and not let the incident become a major incident, and to have it resolved without the stakeholders, the passengers, the audience ever even noticing that, you know, the whole environment is safe and the incident didn't become an incident, so to speak. Continuity really is the number one goal. And with that, I want to show you
D-Fend Solutions and Foreseeing is an advanced autonomous counter-drone system which takes control over rogue commercial drones and lands them safely in a designated safe zone without affecting legitimate drones and without interfering with other communication signals such as Wi-Fi and GPS. Foreseeing offers the ultimate in operational flexibility. System assembly is quick and easy. Readiness is achieved within minutes. The system's core elements can be easily transferred, mounted, and configured to help maintain continuity while on the move. Foreseeing is now operational and monitoring the area for any rogue drones. 2 unauthorized drones enter the defined pre-protected zone, immediately triggering an alert from the system. The unauthorized drones' GPS locations are identified, as well as their home locations, which indicate the pilot's locations at the time of the drone's takeoff, helping law enforcement or special forces to find the pilots and prevent future incidents. Foreseeing initiates and executes the mitigation process for each of the rogue drones. Foreseeing's takeover technology is activated, and the 2 pilots lose communication signals. They cannot control their drones or re-establish the connection between the drones and the remote controls. Both drones have been taken over and rerouted by Foreseeing to the designated safe landing zone. Both drones land safely, ready for collection and inspection at the predefined landing point. With Foreseeing, D-Fend Solutions safely ensures the smooth flow of communications, commerce, transportation, and everyday life.
Great, thank you very much for the opportunity. I know we may have to address some of the questions afterwards. Craig, how are we? I guess we've run up against the time, or
yeah,
how are
so,
we?
yeah,
okay.
Aware of time. So perhaps we'll just take one question, and if you can give us a quick answer to that, that would be appreciated. So let's take a look. So what are the most important best practices for fending off drones at airports? What would you say?
Sure, I know, and I presented many, but if I had to select, probably the most important one would be the focus area I mentioned before. Focus. Be sure to do an assessment. Focus on what is the highest risk in your situation. The most dangerous drones, those that can have the heavy payload, accessibility, and long distance. Be careful on relying on technologies that could disrupt your airport operation, and also maybe this is a new factor as well. Given a complex airport operation, you want to monitor the input from multiple drone detection systems. So you probably want some sort of command and control that gives you a single view of everything that's happening. I see in the chat we have a lot of other questions, but I guess we'll have to address them with some follow-up. But I thank the audience for their passionate participation in this session.
Excellent. So yes, unfortunately, that's all the time we have for today. Jeffrey, thank you so much. Excellent presentation there. So thank you again.
Thank you.
A message to the audience, please do check out the sponsors and exhibitors page on the platform where you can find out more from D-Fend Solutions and to also connect with their team. Next to come on the agenda for the summit is an in-depth webinar into the topic of airport security. So we hope you can join us for that one. Jeffrey, again, thank you and goodbye.